So, this is already started? Okay. Hi, everyone. I'm Giorgia Pollina, and I'm a postdoctoral researcher at the University Observatory in Munich. And you might have heard my name associated to some of these institutions or efforts. But today I'm gonna talk about emulating the void density profile and the void size function through Gaussian processes. So the motivation for this kind of work is pretty straightforward. Voids have gained a lot of, a lot of popularity as cosmological probes. But we're still missing some of these very simple tools to predict their zeroth and first order statistics. Meaning we're missing something that is just like given a set of cosmological parameter, we just push a button that in this case is going to be an emulator based on a Gaussian process. Oh, okay, I have a typo here, but fine. And this would give us directly the void size function, and similarly, given a cosmology and a typical void size, by pushing another button, we can get how the void density profile should look like, which is something like that. And in order to achieve this, then I use a suite of simulation that were designed specifically for this kind of purposes, meaning building emulators. And these simulations are the Aemulus suite. We have at our disposal 14 training cosmologies and 7 testing cosmologies with 5 realizations each. And the parameter space is explored as depicted here. So the idea then is very simple, and we just measure our target observable at all points in the training space. Then we interpolate this observable with a trusted function. And with all this information at our disposal, then we can use the Gaussian process to build the emulator. And our target at that point is going to be the best fit to the measured observable. And I just want to quickly stress that because of basically there is a high statistical uncertainty on how many large voids we can observe, this is just physically, this is just due to physics. We should keep this in mind when we look at the void size function at large void radii. So probably I just have 1 minute left, so I'll just jump to the results, and we can see that when it comes to the void size function, the emulator works impressively well. I think the plot is self-explanatory. So the emulated profile overlap almost perfectly with the best fit to the 5 realization in this particular point of the test space we are showing the result for. And similarly, also the void size function emulator works fairly well because I mean the emulation is still in between all the lines that come up in the 5 different realizations. And as I mentioned before, the large scatter, a large void radii is just physically there. I mean, it's due to the sparsity of large voids. Just to quickly mention, because I think I'm running out of time, these also work outside the Aemulus framework. So these are results from an external simulation, 2 redshift, both for the void size function, the void density profile that I showed before, and the void size function. So that's it. And please talk to me if we want to chat about this a little more. Thanks.
Thank you very much, Giorgia.